Hello, my fellow chemists. In this video, we're going to take a look at electronegativity and how it can be used to determine whether two atoms will make an ionic bond or a covalent bond. This is labeled as an intermediate video because it does assume that you know the basic definitions of ionic bonds and covalent bonds. If you need a review of that material, I'll put a link in the upper right-hand corner. So electronegativity is defined as the ability of an atom to pull electrons towards itself. We have a periodic table up here on the screen, and it's not your regular looking periodic table. These decimal numbers down here are not the atomic masses, they are the electronegativities of the atoms, or how well the atoms can pull electrons towards itself. And you can see that fluorine up here in the upper right hand corner has the highest electronegativity, while francium down here in the lower left hand corner has the lowest electronegativity. And if you remember, the basic trend for electronegativity is as you go diagonally across and up the periodic table, the electronegativity increases. Well, how can we use this trend or this knowledge of electronegativity to determine if two atoms that come together, will they undergo an ionic bond or a covalent bond? Well, what you do is you look at the electronegativity difference between the two atoms. So if we make a chart listing the electronegativity difference, and right at the middle we put 1.5. And then we can go all the way down to 0 as far as a difference of electronegativity. That would be if two of the exact same atom were bonding with each other, they'd have the exact same electronegativity, so their electronegativity difference would be 0. And then theoretically all the way up to infinity, but you're never going to get that high. If you have a electronegativity difference between two atoms that are bonding of 0, you're going to have a covalent bond. And if the electronegativity difference is 1.5 or greater, you will have an ionic bond. And if the electronegativity difference is greater than 0 but less than 1.5, you'll still have a covalent bond, but it will be a polar covalent bond. So let's take a look at this rule of determining the differences in electronegativities for a couple of atoms. So we'll start off by looking at, say, carbon and hydrogen. Carbon has an electronegativity of 2.55, and hydrogen has an electronegativity of 2.20. So carbon and hydrogen. Carbon's is 2.55. Hydrogen's is 2.20. If you look at the difference between those two, you come up with 0.35. 0.35 is less than 1.5, but it's greater than 0. So that means that carbon and hydrogen would make a polar covalent bond. Okay. Which makes sense because they're have similar electronegativities, but not exactly the same. So neither one of the atoms is going to be able to directly pull electrons away from the other atom. If we take a look at another example, let's say now that we take a look at two oxygen atoms. So oxygen is right here on the periodic table. So if we had two oxygen atoms and they were going to make a bond with each other, each oxygen atom has a 3.44 electronegativity. And if you subtract them from each other, you get a 0 difference, which means oxygen would be a pure covalent bond. So you'd have two oxygens bound to each other, and this would be a pure covalent bond, and this would be an oxygen molecule. Remember, molecules are when you have two or more atoms that are bound to each other. So we saw an example of a polar covalent bond and an example of a pure covalent bond. So now let's take a look at an example of two atoms that would undergo an ionic bond with each other. And we'll take a look at chlorine and lithium. So chlorine is all the way over here, and lithium is all the way over here. In general, the further apart atoms are from each other on the periodic table, the higher the chance that they're going to undergo an ionic bond versus a covalent bond. So chlorine has an electronegativity of 3.16, and lithium has an electronegativity of 0.98. If you take the difference between those two, you get 2.18. And we can see that 2.18 is greater than 1.5, so therefore chlorine and lithium would produce an ionic bond if they were bonding to each other. So now that we know the basic rule, if you have two atoms that have an electronegativity difference greater than 1.5, it's ionic. Less than 1.5, it's either going to be polar covalent or covalent. Is there any kind of a shortcut that we can use? Because you're not always going to have access to a version of the periodic table that has the electronegativities written on it. And it turns out there is a pretty nice shortcut that we can use. First off, if you remember how the periodic table is divided up between metals and nonmetals, it's kind of a zigzag line going down here. And everything to the right of that zigzag line is a nonmetal, and everything to the left is a metal, with the exception of hydrogen. So everything over here, these are all of our nonmetals. And we don't want to forget about hydrogen, so I'll circle him too and put him as a nonmetal. And then everything else, basically everything else that you could have in the periodic table, these are all labeled as R metals. And the shortcut that you can use is, if you have a nonmetal and it bonds with a metal, it is going to undergo an ionic bond. And the reason why is, if you look at the metals, they have fairly low electronegativities, and the nonmetals have very high electronegativities. So the difference between the metal and nonmetal electronegativity is going to be 1.5 or greater. If you have two nonmetals making a bond with each other, they're going to have fairly similar electronegativities, so therefore they're going to make a covalent bond. So the shortcut that you can follow is, even if you don't know what two atoms' exact electronegativities are and you have to decide, well, are they going to undergo an ionic or covalent bond, as long as you know, are the elements metals or nonmetals? If it's a metal and a nonmetal, it's going to be an ionic bond. If it's two nonmetals, it's going to be a covalent bond. So that's kind of the shortcut you can use without actually having the values in front of you. All right, that's it for this lesson. I hope you learned something. If you did, subscribe and like, and I will see you in the next video.